Okay, welcome back. So we'll get started where we left yesterday. If you remember, like in the previous module, we were looking at this overall, like how to go about doing an integrated waste management plan. I think we have spent enough time on it. So just to give you a quick recap, this is what we were talking about in the last video, towards the end of the video, like how to go about developing an integrated waste management plan. And now today we'll go into talking about more in detail about the thermal conversion. I explained to you how this thermal treatment fits into the integrated waste management plan as part of our discussion yesterday. So now let's look at this thermal conversion in the details of, like, the technical aspect, the technical details of this thermal conversion. So thermal conversion, it can be done if you think about thermal treatment or waste combustion. We have been we have been torching our garbage, we have been putting the waste on fire since a long time. There has been a practice in agriculture that at the end of the harvest season, some of those like agricultural waste which is left on the field itself, the farmers will put things on fire, and then that burns, and that also adds some nutrient value to the soil. So there is a benefit of doing that, and of course there is a there is a problem of doing that too, in terms of the air pollution and all that. But since in the old days we were not that much aware of our air pollution, not much aware of that the burning will cause some this particulate matter and all those dioxins, furans, and those agricultural waste actually will not create dioxin and furan unless they will create mostly soot, particulate PM, and some maybe if sulfur is there, nitrogen is there, some SOx and NOx may be created. But in most part those dioxin, furan, polycyclic aromatic hydrocarbon, and those things happens in the presence of chlorine, and so plastic actually creates, so because of the plastic coming into our waste, this waste incineration, uncontrolled burning of garbage or open burning of garbage, as we see it in many places in our country, in India. If you just drive around the countryside, drive around near the dump site, you will see for many times the waste is put on fire. And the reason it is put on fire is just to reduce the volume of garbage, so that the volume of garbage is reduced, and you can use that as a part of to the space that is created on the landfill can be used to put more garbage on top of it. So that's the reason why many times you see the uncontrolled burning, and many times people burn garbage on the backyard as well. So those are relates to a lot of air pollution issues, and there has been documented like a research now, which documented report done by United Nations Environmental Program, UNEP. So if you don't believe me, you can believe the UNEP report, which says that uncontrolled burning of waste, uncontrolled burning of garbage is the #1 cause of dioxins and furans in the world. And dioxins and furans are one of the most nasty air pollutant that we can think of. It is considered as a carcinogen, and it can lead to different type of disease. So that's and of course there are other pollutants out there as well. So we have been burning garbage for a long time. Uncontrolled burning of garbage has been going on since many years, probably centuries, and then is still continuing in several parts of the world. But from time for last few decades, we have been focusing on doing what is known as the waste incineration in a thermal treatment plant. So where we are treating the garbage, so we are basically taking the waste, and when the thermal treatment part, treatment is more, we have got that name from hazardous waste, because the hazardous waste thermal treatment is very popular. There the focus is not that much on energy recovery. Their focus is more on collecting, make this hazardous waste less harmful. So when you burn this hazardous waste, or even for biomedical waste, so as per the biomedical waste rules of India, our Indian rules, or even that's pretty much everywhere in the world, it requires that big hospitals should have their own incinerator. And when we say incinerator, it's basically a thermal treatment unit, and it has the air pollution control system. So it's a highly engineered system, and so they will have their own incinerator unit, where they should burn this garbage, and if they don't have their own, they should have a tie-up with a waste incinerator where this biomedical waste is sent, and that biomedical waste is burned on those in a controlled environment with all this proper air pollution control system, and this ash that is produced is no more harmful, because all the pathogens, bacteria and other stuff will be burned, and then it's whatever is coming out, it's it's non-harmful, and that can go to a landfill, and things could be recovered from that as well. So that's part, that treatment name came from there. As for the municipal solid waste, what we are doing is we are essentially trying to generate energy from this. So that's, we use more of a term of waste to energy. Although when we say waste to energy, even the anaerobic digester is also waste to energy. When you talk about anaerobic digester, which is you produce the biogas and then you use the biogas for energy purpose. Landfill gas to energy is also there. Like if you operate landfill and then you collect the gas, these days there is a concept of bioreactor landfill as well, where you operate landfill as a treatment system and then you collect the gas, and then you use that gas for energy purposes. So those things are also done. But when we talk about waste to energy from a waste incineration point of view, we are talking about essentially the either incineration. There are different types of incineration we'll talk about, and so the more broader term is thermal conversion. So where we are trying to do some conversion, we are trying to convert the material. As I have been telling you several times that whatever material is there, we cannot really destroy it. We are only converting it. We are converting it to one form or another form. It's, you may have heard me saying several times that anything on the periodic table, we as a human does not have the power to destroy those. Essentially, we can only change its form, either from one form to another form, something less useful form to more useful form, less leachable to more leachable, or vice versa, more leachable to less leachable, but we cannot really destroy it. So thermal conversion, it's where we are trying to do the volume reduction. One of the major aspect here is to do this volume reduction. So what is this volume reduction? If you start with say 100 tons of garbage, or you end up with 10 tons. So you are almost 90% volume reduction happens in if you go for a waste incineration process. And also we are looking at the energy recovery. So when we are talking about energy recovery, the calorific value becomes very important. So calorific value and is very important of the garbage, and that's what I was trying to tell you in the previous video, that we have to be really careful with this calorific value. We need to really assess the calorific value very carefully, and for the waste which is coming at the dump site, or at the waste to incinerator, because the waste composition, especially in developing countries, it keeps on changing. Like what is produced at my home and what will end up at the waste incinerator gate is different, because there are kabadiwalas, there are rack pickers, and there are other like animals eating some of those organics. So the composition keeps on differing, and we need to be careful in terms of where we collect the data from. And it is an important component of an integrated waste management plan, which I was trying to explain earlier. It's standalone are not always the best. You cannot just have waste to energy system. So if somebody comes to you and tell you that we'll set up a waste to energy plan, say for like a small, let's take a small city example. For example, say even for Kharagpur, I'm sitting at IIT Kharagpur campus. Just outside the campus, we have a very I would say like an important city from the point of view of Air Force, from the point of view of railway, and so it's important. So if for the Kharagpur town or Kharagpur, if somebody says that we'll set up a waste incinerator and we don't need anything else, we don't need a composting plant, we don't need an anaerobic digester, we don't need any waste management, only waste incinerator will do your job, I think that's a person is just trying to fool us. So it's not going to work on its own. Of course, it can be part of the solution. So that's why integrated waste management plan. The name is you have to have different components in there, and waste to energy or this could be an important component, especially for the part of the waste which has high calorific value, relatively high calorific value, which can be used for the treatment in these systems. In Europe, incineration is becoming a larger and more central component. Why? As if you go to any country which has less land, high population density, less land, cannot have landfills, they cannot just put all the waste into the landfill, waste to energy, you will see more there. Other thing is the regulation also supports. In the European context, the regulation actually supports waste to energy. In US, it's not that much, because the US is still relies. US is depends on which state you are, but most of the states still relies on landfill as a major way of disposing their garbage. Although there is a lot of popularity these days on doing anaerobic digestion, and of the sludge from AD can be go for composting. There is also waste to energy plants are coming up. Same thing in China. Lots of waste to energy plants are coming up, but usually they are in combination with other systems in there as well. But in Europe, you see more and more waste to energy plant. Again, China is trying to build more and more waste to energy plants as well. And say some countries like Sweden and other places where they have even they are importing garbage from other European countries. They are importing garbage so that they can have this waste to energy plants running. Many places in Sweden, especially those cold countries, what they are using, the energy produced from waste to energy plant is used for district heating. When we say district heating, it is the heating of the homes in the surrounding areas. So since the winter is there every year, and then with more and more recycling happening in these Western European countries, they don't have enough garbage to feed those big incinerators they have built. So they import garbage from those European countries which cannot meet the European Union target of diversion. Like diversion means how much waste should not is away from the landfill. We talked about that earlier. Diversion is the term used for waste which is not going to the landfill. So to meet the diversion target, some of these countries like Poland, even UK, they send their garbage to Sweden, and it gets burned in Sweden. Swedish people use that as energy for their home heating, and it's kind of win-win for both. But it's again the waste is traveling. If we should do a life cycle analysis to find out what's the real footprint, because of the transportation does release with the use of fossil fuel and other stuff, transportation will release like carbon dioxide and other gases. In India also, even for last several years, like I would say almost 5-6 years now, since the time of when I think a few years back, when Honorable Finance Minister was Mr. P. Chidambaram, he first announced where we were trying to promote waste to energy in India. There was in budget, there was a specific provision for waste to energy, and the waste to energy plants are being built up. In Delhi now we have 2, and there are other places. From time to time I do see RFPs like resource request for proposals or DPRs being requested to do a waste to energy plant. So waste to energy is becoming a talk of the town, like in Indian context. We did had some poor experience with waste to energy. I was talking to you about the Timarpur plant earlier. So but Timarpur is past now. Things are much better as long as we do things properly. Again, we need to design our plants properly, make sure we collect the real data, and if the calorific value is low, so be it. What we can do, like our kabadiwalas does a great job, rack pickers also collect some of those stuff, so our calorific value will be always low if we compare us with the US and other other Western countries, but we have to work with those calorific value. There are companies now which claim that even with low calorific value things are going to work. Of course we need to check those claims, but at the same time we first have to realize that our calorific value is low, and then how to make waste to energy work with this low calorific value. And so that's what, but there are, in terms of the government policy, the waste to energy is promoted as per the present government policy as well. Even in UPA 2 it was there, and present government is also is promoting this government policy on waste to energy. So in this particular section that we will be covering in this course, the focus will be more on analysis of the conversion system, like which conversion system is best to use where, and what will work in what context. We will talk about design, but we will not go into like a nitty-gritty detail about the design, because that itself will kind of become like a course for a few weeks. So we will not go in very detailed design, and if you are interested, like a week I can contact me separately, and then I can provide you some information on how to go about that. But in in the course will be more in terms of design. We'll do some design, but we'll just do some basic design. We'll not go into the detailed design, as you saw in for the composting and anaerobic digestion as well. So we'll discuss the principles. What are the principles of thermal processing? Then we'll go over the details of these processes so that you understand, and which process to choose based on your waste composition, because that's the number one thing you have to do. Once you have figured out which system is going to work for you, there are companies out there which will provide you the technology, and if you need help, there are people like me available in the country who can help you with choosing the best technology that will work for you for that particular process. But first you need to understand, like to make a waste to energy work, what things should be there and what mistakes we should not make, because so that we have a good waste to energy plant working. So in terms of the process, there are essentially there are 3 or 4 more, there are 4 listed over here. Reason I said 3 or 4 because the last one is mostly for hazardous waste, but let's talk about them. It's in terms of their process: combustion, which is you hear the most, and combustion means essentially you are burning, and you are burning in a controlled environment. So that's the combustion part. So combustion is thermal destruction of in the presence of oxygen. So you need to have oxygen. So if you remember that fire triangle where you need some you need oxygen, you need a ignition source. I'm not very good writing with this, but that's the ignition source. You need oxygen, and then you need something which will burn. So this is your like a combustible material. So we have combustible material, we have the ignition source, and then we need oxygen. So these 3 is needed. Otherwise, you must have heard about fire triangle or in your any class earlier. So essentially, what it does is you have you need and what is happening here? It is in the presence of oxygen. So it's an oxidation process. So combustion is an oxidation process, and what will burn? It is all those volatile solids. The volatile solids is what is going to react, and we'll talk about that with the pie chart again. The volatile solids, how we identify volatile solids? You take the sample, you put it in the muffle furnace at 550 degrees centigrade over a period of I think 72 hours, and then you look at the loss of mass before what you may weigh the initial mass with the crucible. After you take it out from the muffle furnace, you weigh it again. The difference gives you the volatile solids. So that's what is going to react in this particular process. And in terms of this, what is there in terms of, if you go to the individual element, it's mostly carbon, hydrogen, oxygen, nitrogen, the sulfur, those things are present. And once they react with oxygen, what they will produce? They will produce carbon dioxide, they will produce moisture vapor, they will produce sulfur dioxide, they will produce nitrous oxide, NOx, SOx, NOx, and N2O, NO2, depending on the reaction. Could be carbon monoxide or carbon dioxide, again depends on the reaction. So these are the things which will, so if you know, again we have to know the formula of this volatile solid, and we'll go there. So but in terms of the process, in terms of the, we have combustion, which is essentially a oxidation process. There are different names given to the combustion. We have incineration, cogeneration, energy from waste, or co-incineration. And most of them actually, incineration is you have the waste coming in, you are putting into an incinerator, and then the waste is like it's burning, it's producing energy. You are the heat. That heat is used to feed the boiler, and the boiler makes steam, and steam generates the electricity. So that's with the turbine and all that. So that's how things work, and that's so basically here, rather than using, say if you compare this with a coal-based thermal power plant, rather than using the coal, you are using waste as a energy, as the fuel. So that's what it is. Then cogeneration is when you are actually trying to mix something together. Energy from waste is, which is essentially you have you in the incineration plant, you may not be collecting any energy, you are just incinerating it for the sake of thermally destroy it. But when you try to do energy from waste, your focus is on energy generation. So you are trying to make energy out of that garbage. Co-incineration is when you are mixing with something else. So those are your co-incineration. So I said all those things are essentially it's a combustion process. That is what it is. And then in terms of combustion, since we have to supply oxygen, and as part of this particular course, we will do some calculation like how to find out how much oxygen will be required to be supplied and all those things. Now, the second part is when we talk about is the pyrolysis. The first part, combustion, is in the presence of oxygen, pyrolysis is in the absence of oxygen. So, you have you do those things in the absence of oxygen. It's in terms of the municipal solid waste, like a general municipal solid waste, you do not see that much pyrolysis plant. Pyrolysis plants are there which are operating for kind of some specific waste. For certain specific waste stream, pyrolysis works, and pyrolysis is used as a process for thermal treatment, but for in general municipal solid waste, you do not see that much of pyrolysis plants out there. Gasification, where you do partial combustion. You do the partial combustion to generate a combustible gas. So, you do not do 100% combustion, you do a partial combustion and you produce combustible gas, and that combustible gas could be used as a fuel source so that is another thing that is done in terms of the process. Then plasma arc. Plasma arc is you are actually superheating a gas to an ionized state. So, plasma arc, what you do, you take the waste and heat it all the way to almost like 10,000 degrees centigrade. So, it is a highly energy intensive process. So, if you remember in the beginning I said usually we do not see plasma arc plant for municipal solid waste. The reason for that is it is a highly energy intensive process, and if you think about an Indian context, when our calorific value is already low, and if I want to use an energy intensive process, what I'm actually, we will have a net energy will be negative. When I say negative means rather than producing energy, it will be actually consuming energy, because to make something to up to 10,000 degrees centigrade, it's not a joke. Even if some technology works from around 5,000, 6,000 to 8, so it ranges from 5,000 to 10,000. So it requires a lot of energy to do that, and if the plant has to really work sustain like on a long term basis, it should produce energy, at least it should be self sufficient on energy, so that you do not have to supply energy from outside. So, that's I do not think is it's really work, especially from an Indian garbage perspective. You do not see, I have a hard although there are some vendors out there which are trying to promote plasma arc as a municipal solid waste treatment system, but I have my strong reservation on that's really going to work. We have to be really, if we are going for that, if any ULB in the country wants to go in that route, they should actually do this energy balance calculation. They should be really sure about the energy, and because that's where later on there will be a problem, so that's the it's a superheating. You put it all the way, you completely destroy the chemical bonds, and then what happens is it actually takes it to all the way to what is known as the vitrified slag, and then you can use that slag as a construction material and all that. Of course, you have to look at any heavy metals present, potential leachability issues, and all those things needs to be done, but those are not that difficult. Some tests needs to be done in the lab, and people can several labs can do that, and so that's can be tested and to find out whether it can be potentially used as a construction material. But for hazardous waste management, plasma arc is used in many parts. Plasma arc is used for hazardous waste, because hazardous waste treatment is much more costly. It's sometimes even 100 times more costlier to manage a waste as a hazardous waste than a non-hazardous waste. So economics works in terms of hazardous waste to go for plasma arc. For municipal solid waste, I am not sure, like I have not seen any like a full scale working municipal solid waste plasma arc facility which has been operating for quite some time. So it could be that if energy required is much less now because of some improvement in technology, which I don't see how, like it could be possible, but I have not seen any. So that's so we still have to look at this plasma arc. So that's basically leaves it down to essentially for the waste to energy, we mostly focus on this part in general for municipal solid waste. For municipal solid waste, we are focusing here. For some of the specific waste, there is pyrolysis and gasification is also done. So these are the processes which is out there. Now, so in terms of the process, now what composition of what fraction of the waste which will react in these process, whether you use one or the other, as again, if you take the pie chart, if you take the composition of the waste and put it as a pie chart in form of from the combustible characteristics from the so here you already seen this side way, I think in the first week or the early second week. So any waste stream you pick up and do this composition, you will have some moisture, moisture, then there will be some inorganic fraction, some of the inorganic will be there. Then we have some ash and fixed carbon, which is always there. Fixed carbon is the amount of carbon which really does not react, and then we have this volatile solid part. So this is the volatile solid we just explained a few minutes back. This volatile solid is what is going to react in your combustion system. So for calculating the air requirement and other stuff, we need to know the formula for this particular fraction. We need to know the formulae for this particular fraction, this volatile solid fraction, this green fraction that you see over here. So we need to find out the information for that, and that we can use it in our equation. So some examples, say if you look at the mixed food waste, it has water is 70%, and more water bad it is for waste incineration. Why? Of course, water doesn't have much of a doesn't have calorific value. In fact, water will consume energy, because when you have when you heat the things up, usually the waste to energy plant works at around 1100, around 1000 to 1200 degrees centigrade, just to not to have some of those air pollutants in terms of PAH, polycyclic aromatic hydrocarbon, and some of the dioxins and other stuff they produce at low temperature. So we try to work at high temperature to reduce the amount of air pollution coming out. So for that to happen, we need to heat it up at a very high temperature. So when you take the waste with lots of moisture, you are heating it up. So when it reaches 100 degrees centigrade, of course, you have a huge consumption of latent heat of vaporization. If you remember from your high school physics class, as a latent heat of vaporization, the energy is consumed. So energy will be consumed, and then that becomes your negative in terms of the heat value. So with mixed food waste, 70% moisture, it's very difficult as a it's not a good candidate for waste to energy. VS is 21%, fixed carbon is 3.6%, and that's a non-combustible is 5%. Although things here will combust, but the heat value will be very low. The calorific value will be very low. We use heat value and calorific value kind of interchangeably. Sometimes we call it heat value, sometimes we call it calorific value, but they are the same. Then you have a cardboard. Cardboard, here you can see the moisture is much less, only 5.2%. Volatile solids is 78%. So cardboard is a very good candidate for waste to energy. And that's also the very good candidate when we go for the recycling. That's why there is always a debate that if you, most of the recyclables like cardboard, paper, these two, the cardboard and paper, they're very good in terms of waste to energy. Because of a good calorific value, low moisture, but still they are good for recycling too. So if you take it out from the recycling and put it in waste to energy, are we really doing environmental good? If we take, or the other way, if you are taking this cardboard or plastics and papers and then take it to travel it around for several kilometers before it gets recycled, it may make more sense to directly put it in a waste to energy plant. So we have to find out which one is better for environment. So again, this whole concept of life cycle comes in picture, where you can do those type of calculation. So volatile solid, fixed carbon is there some, and there are some non-combustible still, but there is a good amount. The VS is pretty high, moisture content is low, so can be used there. Yard waste, again, lot of moisture, so may not be a good candidate, has a good like 1/3 volatile solid, fixed carbon, non-combustible is also there. So some of those are good, some of them may not be good. Tires are actually pretty good in terms of calorific value, but the problem with tires is it also creates some air pollution issues. There are some, there is a chlorine is there, dioxin furan production from tire burning is a issue, there is heavy metal issue is there as well. So in fact, very recently there was in Nova Scotia in Canada, just a couple of months back, I think it was in July of this year, they were looking at in terms of how like try to burn tire for energy, and people are resisting that because they already had some issues with that almost 20 years ago when they were trying to do it for the first time, and then there was some air pollution issues. Air pollution issues has improved a lot since then. It's becoming more stricter, things are becoming more cleaner, but it's still, if you have a bad experience with certain technology, even if the technology has improved really well, it gets really difficult to convince the people. It gets really difficult to convince the public to go and use that technology again in future. So let's, I think we stop at this particular point for this particular video, and then in the next video we'll continue our how to do those stoichiometric calculation and all that. So in terms of the thermal treatment, there are different types of thermal treatment. For hazardous waste, biomedical waste, thermal treatment is used quite extensively. For municipal solid waste, especially from the Indian context, we have some waste to energy plants now. We had some bad experience earlier, that's why we didn't had any for several, like almost 2 decades, and then we are building some of the new waste to energy plants. One thing we need to be careful about, to have a realistic assessment of waste calorific value, so that when we design our waste to energy plant, we are designing it in a way so that it works, rather than if we have a faulty calorific value to start with for design, it will have problem in terms of its operations. So with that, let's close that video, and then we'll come back again and do detailed calculations in the next one. And again, if you have any questions, feel free to put on the discussion board. Discussion board is the only forum where we kind of respond to your questions. We don't entertain any other forum, so put it on discussion board. We'll be more than happy. Every evening we are looking at it, and we are trying to reply to any query you have. So thank you, and look forward to seeing you again in the next video.